Hello, welcome to Code Live. My name is Kevin Porman, and I'm a developer advocate here at Salesforce. Today, I have a very special guest with me. His name is Rob Cowell, and you'll hear in just a little bit that he is clearly a person from the UK. He's got a great accent there. In preparation for this meeting, I asked him, what's your Hogwarts house? And he said he didn't know, but he was a Mountbatten, which is a fun little fact from the houses he actually was part of as his boarding school. So with that said, Rob, do you want to introduce yourself, say anything fun, interesting, give me a hard time, anything like that?
Sure, thanks, Kevin. So as Kevin says, I am indeed Rob Cowell. I am indeed British, and I did indeed go to a boarding school that wasn't Hogwarts. So I run a small consultancy now called Queueable. Star Wars fans amongst you might recognise that name. I'll leave it as an exercise for the reader. Fun fact about me, I write code that isn't necessarily for Salesforce. I still poke around 80s computers on at least a weekly basis because I just can't let go of the 80s.
I'm curious about that. You held up your Commodore 64C there.
Yeah.
Like, how do you persist your code on that? Do you have like a hard? I mean, I don't think they had hard drives. Do you have like a floppy drive?
No, I have a great little gadget here. You'll hopefully see on the camera.
It's a USB key.
Yeah, there's a USB key, and then this point plugs into the cartridge port
of
the back of the back of the Commodore.
Gotcha.
And yeah, development. You would code on PC. There are what they call cross assemblers. There's all sorts of great plugins and things for Visual Studio Code, which we all love.
Fascinating.
There's emulators, so you can do a run, deploy, test cycle really quickly. And then when you're done, you stick it on USB key and you test it on real hardware. And then you find problems that the emulator didn't cover. You go back and try again. But
awesome.
Yeah, it's good fun. And I do the same with Ataris and all sorts of other old kit as well.
Cool. Now, this session idea popped up, I don't know, what, 2 months ago? On Twitter,
like
we were talking about ways in which you could handle processing huge amounts of data. So the example you gave was, what, 327 thousand records that needed to be processed?
Yeah, kind of. Yeah. So what it was, it's processing the attachments on those objects, right? And it has to kind of do a lookup, see how many attachments there are. So across the objects, there are, as you say, about 337,000 objects. But then each of those objects can have unknown volumes of attachments. So it's just a multiplication math problem.
So your first record could have 8 attachments, your second none, and your third one 34?
Yeah, absolutely.
Okay.
Those would be the good records in this particular org. Yeah.
Oh, right. So you're talking like some of them could have thousands of attachments?
I'd say into the hundreds, possibly.
Hundreds,
hopefully
okay.
not the thousands, but yeah. I mean, either way, it's a big old chunk of data, and when you're talking attachments, you're talking, unstructured binary data as well. So it's not so much the size of that data or the fact that it's a big binary blob. It's more a case of just volume. There's a lot of records that it has to kind of pick up. So
we sort of took your problem and we abstracted it out a little bit. And how do we process thousands upon thousands upon thousands of records? And what we want to work with today is one way of doing that, and it's going to exploit a design pattern, or some might call it a loophole in the governor limits system, and it has to do with working with queueables. Now, we've worked with queueables in the past on Code Live, but this is going to be the first time we've ever done anything quite like this, and I want to draw your attention to the execution governors and limits page. If you're like me, you probably have this bookmarked, and you read through it on a fairly regular basis, confirming that the particular thing you're looking up is right. So when we look at this table of governor limits, we've got the synchronous limits and we have the asynchronous limits. And because we're going to be dealing with queueables, we have the ability to look at this asynchronous column. And of course, it looks like what we've done is we've changed the heap size, we've changed the maximum CPU time, and we've changed the number of sockle queries that we can run. And those are the big differences we get with that asynchronous side of things. And so we're going to be working with that queueable in order to try and bite off chunks of data and then process and process and process. And the way that works has to do with a little bit of I don't know, some people call it a loophole in the way queueables work, and that is a queueable can re-enqueue a queueable. Or it can, let me rephrase that, a queueable job can enqueue another queueable job, and that new queueable job can be the same one, the same class that you're in right now. So you can re-enqueue yourself. And the caveat here is that in Scratch orgs and dev orgs and in trial orgs, your queue depth is limited to 5, which means you get the one you kick it off and then 4 more. So you can sort of prove out in a small scale the way this works, but we're not going to be able to demonstrate it with the large data volumes, which is okay, because it's also really hard to create large volumes of data in a 5 megabyte storage org. Now, in production, there's no max queue depth. So
unless you're in a test context.
That's true. So if you're in production and you're not in a test context, there's no there's no queue depth. I was looking on here. I thought there was a queue depth, and I was thinking there was one. There's not. We've got the total stack depth for any Apex invocation that recursively fires triggers, and we've got there's one here on triggers. We don't have one for queues, so the queueables. So aside from the fact that you can only have in the queue 50 items at one time, you can, as you burn one queueable down, you can spin up another one and keeping that one of your 50 slots in the queue going for this particular process. So we talked about this and we built out this idea. We're going to implement it today, and it always goes back to the idea that how do you process large amounts of data the same way you eat an elephant. Why you would want to eat an elephant, I don't know, but that's the expression. The story I always heard was, how do you eat an elephant? One bite at a time. So how are we going to process these massive amounts of data? We're going to do so one chunk at a time. So I've created the LDV recipes folder in our classes and in our test folder. LDV stands for large data volume. Now, if you're an ISV, you can ask for a partner developer edition org to be created with large data volume enabled on it. And that allows you to create massive amounts of records and test your code against chunking through all of those. But if you don't have one of those, if you have just a sandbox or a production org with hundreds of thousands of records in it, like Rob did, you've got to be a little bit more creative. So what we're going to be doing is building out this large data volume recipe and demonstrating it with small data volumes. So through the magic of television, hand waving, we'll see what's going on. By the way, just remember, if you like this, feel free to subscribe and hit the like button. That'll help us know, what kinds of content people are looking for and help guide that discussion. Also, we've got the chat available to us, and if you'd like to leave us questions, comments, or snide remarks, you'll see me turning my head over this way to look at the chat. Hecklers encouraged, leave us comments and questions there. So with that said, with all that sort of housekeeping out of the way, let's go ahead and start this. I'm going to create us an LDV recipes class, and I'm going to say LDV recipes, and I'm going to put it in our custom LDV recipes folder. And Rob, we need to make this a queueable.
Yeah.
You want to take care of that? I'm going to put a little comment here at the top. Demonstration recipe for how to process a large amount of records in serial chunks using queueables.
I'm so glad for these plugins that do my typing for me, because I really cannot type the word queue. It's too many vowels in a row.
Yes, I agree.
And we're going to be fighting over where we're putting the curly braces, I can just tell.
You can put them wherever you want. As soon as I hit save, it's going to properly format them.
This is going to turn into one of those conversations, I think. Yeah.
Yes, it is. See,
code style fights.
I'm going to hit save there, and then, like, it should totally... It didn't do it. I don't... What's going on? You're failing me, computer. My tooling's failing me. Hey, look, there it did it. So with the execute method, we also need system queueable execute. LDV recipes must implement. It's not static.
No. Okay.
That's why I didn't like that. Okay. And I just spun up this one, so let's do this. npm install. Let it do its thing over here. And let's look at our debug, our output. And must implement. It doesn't like public.
You know what it is.
Oh, we're in the constructor.
We are in the constructor, yeah. Okay, go on. You drive.
You cut it, so you get to paste. I don't have it in my pasteboard. Let me put this in.
Well.
There we go.
The joys of two people typing at once. Always fun.
Yeah, you know. Okay, so we got that. I'm going to save this so that we can clean up our error messages here. We got the execute method.
Yeah. There we go.
Now, why did we duplicate the Okay. And what I'm going to do here is I'm just going to leave some notes. So, point of interest 1. Points of interest. I'm going to switch back to Visual Studio to this over here. We can retrieve 50,000 records by SOQL query. Or we can
that raises an interesting question.
Yeah, what's that?
So originally, when I was kind of trying to eat this elephant, I was using batchables. So in the start method of a batchable, if you inline your SOQL query into your start method, you can actually pull out 50 million records. Does Queueables not have an equivalent to that, or is that just a batchable start method thing?
50 million. Oh, interesting.
Okay. You know where you set up your scope, you know, your context.
Yeah. No, I know exactly what you mean. Let's illustrate it though. Let's do batch recipes. Batch recipes class. When you implement the database batchable, you have to create your query locator start method.
Yep.
And this one's doing a query locator, which is going to be using this limit, but you can inline it to have this return the query.
Yep.
And that would give you the ability to do 50 million.
Yeah.
I think that's probably limited to just batches. I don't know of a parallel for queueable.
Yeah.
But we've got 50K records, not account records that we can use. We have 60 seconds to do it. And we can re-enqueue one queueable.
Yeah.
Now the fun part about this is we can construct these, and this is where I think queueables are sort of like, when I think of asynchronous development in Salesforce, we can do batches, you can do at futures, you can do queueables, my first go-to is always queueable because they're constructible like this. And constructible. So if we were to create a public LDV recipes, our constructor could actually do that work of getting us the query chunk, and our constructor can also accept a pass-through variable. So let's do this. Let's do integer offset, and I'm going to do private static final integer, and this one's going to be our chunk size.
So I guess this is a key difference between the queueable and the batchable, and then the batchable will do this kind of chunking and heavy lifting for you.
Yeah, and if you want to use a batchable, that's totally fine. That's a different show, basically, right? Hey, somebody's asking a question though. Why we're thinking about processing LDVs and sequentially using queueable Apex? We already have batch in place because, again, number of asynchronous Apex method execution per rolling 24-hour limits. You're right, Majunith. There are lots of different ways, as it turns out, to skin this cat, to use another strangely questionable animal metaphor. But for eating this particular elephant, we're going to use queueables. The reason you might want to use queueables rather than batch jobs has everything to do with other things that might be associated with the work you're doing. So in Rob's original case, you were going to make a call out to AWS S3, right? You were moving those files to S3. Now, when you do batchables, you can make call outs, right? I'm not wrong in that. It's been a while since I wrote batchable. So you can make the call outs in batchable. The question is, how do you handle if you hit that time limit, that 60-second timeout, and you've only uploaded 14 of 500 of your files because those file uploads are taking longer than you would like? And the reason I go for queueable in this situation, Junith, is that I can look at what the queueable did or did not accomplish in a finalizer, an Apex transaction finalizer, and see exactly which record I need to start with again, where to start again. So, I'm going to set a chunk size here. We've got the variable for the offset. I'm going to set this to be a private integer. We'll do offset is equal to we'll do it's equal to 0.
And there's some interesting techniques that can be done as well around the setting of those limits, should we call them, because they are kind of driven by the limits. So I had an interesting conversation with Amnon this morning. Hopefully a lot of the Salesforce devs here will know Amnon, one of our MVPs. And we were talking about some of the sort of techniques for limit management, and what he actually does as a framework is he will read off the maximum limits that from the system.limits, I think it is, and then he'll multiply that number by 0.75. So he'll say, okay, let me know what 75% of the available limit is, and then when I hit that threshold, then trigger a new queueable job, because that way he knows it's always within tolerances. He knows he doesn't have to change that code if Salesforce increase or, God forbid, decrease those limits. It'll just work. I thought that was a pretty slick technique.
Yeah, you're jumping ahead of where I was going to drive us, but that's exactly the trick I was going to do. But I was going to sort of stub this out so that we see what's going on here. And we're going to say, if offset is not, I can type null. This dot offset is equal to offset, and then we're going to run a query we're going to go... Nope. Wow, my keyboard shortcuts are struggling today. Private.
Yeah, it's that weird keyboard you got.
Yeah, probably. List. Let's do accounts. Just because I happen to know that we've got a few hundred accounts in place.
Sure.
List accounts, and we're going to call this one objects to process. That, and that's right, it's not accounts, it's account.
Mm-hmm.
Way to go, typo, Kevin. And then what we'll do is we'll do this dot objects is equal to select, format this, select ID name. For right now, that's all I'm going to pull from account. And feel free to jump in here and like correct me or whatever as you see fit here.
No, I'm just pondering the validity of a SOQL query inside a constructor. But I guess in this context where it's a queueable, you know that you're only going to be running one of those queueable jobs at a time anyway.
Exactly.
So you should be okay. Yeah.
It's a design.
You wouldn't do this in a normal constructor,
right? This is not something I would normally do in a constructor. We could refactor that out of the constructor, but I think in the situation where it's a queueable, it actually makes sense.
Mm-hmm.
Right? So from accounts, order by ID.
And again, with the kind of volumes that we're talking at as well, you would not want to do a stateful on this either to try and preserve where you got to.
Exactly. So we're going to do order by ID, and we're going to set it to limit. And we're going to put in this dot chunk size.
Mm-hmm.
So we're never going to pull more than 50,000 records. That's 500,000. I want 50,000. That's better. And then what we're going to do is we're going to say offset. And we're going to do this dot offset.
And that's kind of a similar technique for sort of other sort of relational databases as well, with the whole sort of offset window. It's quite a common thing, not just used in Salesforce.
When I learned this technique, it was actually on Oracle, and we called it creating a cursor.
Yep.
And I have no idea where the terminology of a cursor comes from, but that's the name I learned it under, is this pattern of grabbing a window or a group of records and processing it and then going on to the next one. So when we create our instance of the queueable to enqueue, we can initially pass it 0 because we're going to start off there. And the first thing it's going to do is grab the first 50,000 records. And then when this is done processing, we want to go down here at the very end of this and say, create a new LDV new queueable is equal to new, and this time we're going to pass in offset plus this dot offset.
The offset.
Plus this dot chunk size. And okay, so and then what we'll do is we'll enqueue this.
Would that be offset plus chunk size, or would it be offset plus chunk size plus 1? Because you've gone from 0 to
fixing the off by 1 error right out of the gate. That's awesome. Why don't you fix that for me while I figure out this part? The two classic problems in computer science: naming things, cache invalidation, and off by 1 errors. Somebody's asking, what about the limit that related for offset? Salesforce has a max offset equal to 2,000.
Oh.
I was not aware of that.
No. I must admit, I've not used offsets before, so I'll be...
Salesforce max offset SOQL. Well, that's a problem. Offset. When expecting many records in your query results, using offset is an efficient way to handle large data sets. Because the offset calculation is done on the server, and only the result subset is returned. Using offset is more efficient than retrieving the full result set and then filtering the results locally. Yeah. Offset is only, okay. Maximum offset is 2,000 rows.
Oh,
Search exception.
good catch.
Good catch, Taris. That's amazing. That kind of puts a nice hole in the plan here. But if we think about this, so by the way, rules of code live. Number 1, failure is always an option, right? So thank you, Taris. Now the way to handle this, though, we have other ways of doing this. It is generally safe to order by ID, and then we could turn around and say, instead of handling the chunk size and the offset, what we can do is we can, at the end of processing, so what we can do here is we can say count last record is equal to objects to process, objects to process dot size. Am I going to be off by 1 again? Yeah, I think that's good. ID. And we're going to change this to an ID. We're going to say last record ID.
Yeah.
And then what we do is we change our constructor to take an ID. And we'll call this offset ID.
Yeah.
And then down here, we're going to limit chunk size, but we're going to change this offset portion. So order by ID, and we're going to say where ID is greater than this dot offset ID. And this is going to have to change to ID.
Yeah.
Hey, that's cool. It didn't. So we can do the offset ID. And then what we've got now is whenever we run, that's because I got to reorder that. Where off order by. So we're going to let the database order this for us, and we're going to only grab IDs that are sequentially larger than the last offset ID. And what to do, though, is to make this null. If that's null, we're going to have an issue. That'll throw a null pointer error. So in our... Okay, so we've reached the level of complexity I'm comfortable with for a method. So now I'm going to create a helper method. Private list account. And if you want to move that down here for me, get records to process. And we'll do ID offset ID. There we go. Perfect. And then if offset ID is null, so the easiest way to do is to refactor this into dynamic sockle, right?
Mm-hmm.
And then we can just say, you know, if ID is not null, then put it in there. Otherwise, don't. Because it's still going to order. We're relying here on the order of this. So let's do this. We're going to say string query string is equal to start off with an empty string, and then I will come over here and I will do query string plus equals.
Can't make that work. Yeah.
I'm sorry, what?
No, sorry, I'm just thinking out loud. Yeah, concatenate it all together.
Yeah, and you'll notice I had to be careful about putting a The reason I'm not doing it as a true concatenation where I do plus here is that I want to turn around and make this into a conditional. So if offset ID is not null, then we're going to take this and we're going to change it from this dot offset ID, because now we're using that one.
We got a good question in the chat as well around the use of that ID in the where clause.
Oh, so ID is actually ID. It's a type called ID, and it is not only is it it's kind of a superstring. It's hard to explain. There's transparent bridging between an ID and a string, so you can go from string to ID back and forth without any effort. But they are different, and you do get certain benefits of them. For one, IDs are indexed in the database, so ordering by and doing a where on an ID is much more efficient than doing it on a string. So by doing it this way, we're going to pull in. And we got to put this. We're going to put this back into the query, and semicolon that, and I'm just going to copy pasta this, and this. We'll go over here and do that, and we're going to have to put spaces in here so that it doesn't run everything together. Semicolon, and there we go. We don't need that. And then we can do database return database dot query string, like that. So we've changed our method now so that we can do it based on ID. And if we go up to our constructor, we're going to have to handle calling that method. So this dot objects to process equals get records to process, and we're going to pass in this dot offset ID. And that doesn't really change anything about how we're going to handle this execute method, because we're just going to grab the last ID.
Yeah.
I'm liking how this has come together, and we'll queue that new queueable. So at this point, we're not really doing any processing, as it were, but we are doing the actual work of chunking through this. So with that, I'm going to pause here, remind everybody what we're doing. We're walking through a situation where we need to go through and edit a bunch of records, and by bunch of records I mean potentially hundreds of thousands. And we're doing so in a way, and it's not the only way, but it is a way. We're using queueables so that we can construct and figure out which segment of the data we want to work with at this particular point. And we're going to then, at the end of this, re-enqueue the exact same queueable. So our class is called LDV recipes. And you'll notice here at the end of our execute method, we're creating a new LDV recipes object, and we're passing in this dot offset and this dot chunk size. Speaking of which, that's probably not what we want. We want this dot offset ID. Yep, there we go. Yep. And what's going to happen is that'll re-enqueue at the next job. So we're going to, if we set our, for test purposes, if we set our record limit at 5, it's going to grab the first 5 records, process them, then it's going to enqueue the next one, which is going to have to say the last object's ID, and it's going to say, okay, great, give me the new, give me the next 5, and so forth. So we're able to process this as if we had offset greater than 2000, because we're doing it based on IDs, but we're still within the constraints. And again, Taras, great call out there on the 2000. I hadn't realized there was a limit on that offset. Yeah, so the question now is, Rob, how do we want to, what do we want to do to process these to show that they've been processed? And this is sort of a contrived example, but we're working with account objects. So we can do any kind of editing on the account. We could make a call out to something to demonstrate how we want to make a call out. We could pass that ID, or the record's name and ID.
The interesting part, I guess, or annoying part of the original use case was quite a challenging one, because what we actually needed to do as part of the processing, and that was not to process the records, but to process the attachments on those records and push those to S3. So in fact, there was kind of two stages of bulkification needed. One is to get all the records, which was around sort of 337,000. But then to get all the attachments on those records. So the processing of the original set of records needed to be bulkified, i.e. you needed to be able to query out 337,000 records and then pass that to the method that identifies how many attachments each of those records have got, and start sort of scooping them all up and then passing that result into another bulkified mechanism for processing by AWS. So it's kind of multi-layered, the original requirement. And that's kind of where the fun began.
So let's do it this way. Let's just mimic that. So we're going to find attachments on the account object. Now, out of curiosity, is there a reason you did not go straight to just searching for attachments that were related to a prefix of account?
Yeah, so I mean, what I have got tucked away somewhere. Bear with me just a second. So I've got a piece of anonymous Apex, and
do you want to put it in a buffer here so we can see it?
Yeah, let me just grab that and flip back to. There we go. Okay. So the anonymous Apex would do. What it would do is, it was rightly or wrongly, and I'm open to suggestions, but it would go through content document link and scoop up those content document IDs where the linked entity ID is in. Well, in this case, it's work inspection form content, but pretend that's account for the purposes of this demonstration.
Right.
We can flip that out. But basically, it's saying, okay, go and get me, all the content documents that are associated with an account ID. That's kind of it. Now, if we did that by prefix, we'd actually have to do some processing on the IDs to strip the prefixes out. So it was actually easier just to throw the whole ID out there.
This is easier, yeah.
Yeah. So this part was fine. This would quite happily just go and get that list. And then what it would do was hand off to a trigger handler. And that trigger handler would then hand off to a batch, and then that batch would, and that's kind of where the stack started falling apart, because, even if you've got 337,000 accounts, and each of those accounts has got 10 attachments on average, then suddenly, you're into that large data volume territory that we were talking about.
Yeah, so it almost seems like we need to find a way to buffer. Let's go back to our example here. So we can process the records, and if the first thing we want to do is find attachments on those records on the account object, it seems like we need to find a way to store the attachment IDs in order to be able to process them in a different batch.
Yeah, exactly that.
So in this case, what I might do is do the exact same pattern here, but do a second queueable that processes the actual attachments. Now, what I was trying to get at in my first question to you is, why didn't you do this particular thing? Is it turns out you did. Is you're just going straight for the actual attachments on account. So we could refactor this to use that exact same thing. So let's go ahead and do that, because I think that makes more sense from an efficiency perspective. So if we were to grab this query, oh, wrong thing. Okay, if we come down here, and
I'm sure a lot of the devs on the chat will have painful experiences of trying to traverse attachments and content documents and linked entities and whatnot. It's a structure that works, but it can be quite challenging to work with.
And I often wonder, like, is that I would love to be a fly on the wall during the design meetings for that data structure. I'll put it that way. Come on. I've noticed this thing where Visual Studio Code since the last update, whenever I double click on something, so if I double click on linked entity, it highlights it, but it doesn't actually like highlight it. So I've been struggling with that. So we're going to put this where linked entity in offset ID. Select ID.
One of the other interesting things with VS Code development for Salesforce now is that we're so reliant on helpers and plugins and things here. I mean, you can see here, you've got the orange from your PMD, and then you've got your red from your syntax highlighting and what have you. And suddenly, it starts becoming very difficult to tell which parts are your code and which part are the pop-ups and helpers. So earlier, when we were trying to sort of refactor stuff out of the constructor and into a separate method, it did get a little confusing as to what goes where, and compounded by the fact that both of us are actually on the same VS Code at the same time. Yeah.
And you probably have different colors that you're used to.
Oh, the colors are fine. I use your theme.
Oh.
Yeah, quick plug. Kevin wrote a VS Code bundle with a whole bunch of stuff, including his color theme. Code is in bed by 10 p.m., I think it's called.
Yep, code is in bed by 10. It's for those of us who used to be night owls but now have to go to bed because we have children. Okay, so I've changed this query to go grab us where the LinkedIn ID is in a list of IDs.
LinkedIn ID?
The linked entity ID, sorry. The linked entity ID is in a list of account IDs, but I'm also adding my where clause here where the ID is greater than our offset ID and limit by that's me this dot chunk size. Okay. And what we need to do down here is in this one, we're not going to have that's going to be our objects to process. So we're going to have to grab the objects to process as ID for the last. We don't want to chunk it based off of the account ID. We want to chunk it based off the linked entity ID.
Content document. Yeah, content document ID.
Content document ID or the linked. Well, yeah.
Yeah, because that's. No, sorry, it's just ID, isn't it? On the content document link object, because that's effectively what we're iterating through on the query.
Content document link. So where the ID is greater than the offset ID.
Mm-hmm. But doesn't that need to move to the outer query?
It does.
Yeah.
Actually, we're always going to be doing that. Well, whether or not we do this part, so we can say query string and ID is greater than offset ID.
So here's a question, right? So, with our original scenario, we were talking about 337,000 records of the object. Okay. So you've got that inner query there, select ID from account, right here. Mm-hmm. Is that limited by the 50,000 limit on the inner query, even though we're chunking? Because otherwise it's just going to pick up the same first 50,000 account IDs. And it's never going to move on that piece, because that's not effectively on a sliding cursor window either.
Yeah. I don't know. We'll have to test that.
Sure. It's almost like you've got kind of two parallel cursors. One is iterating through the account, and then within that set of accounts, which is effectively your where clause, you're iterating through the linked documents to identify.
And this is where it might make sense conceptually it might be clearer and easier to understand if we were to separate this into 2 steps or 2 process jobs, where the first time we're going to go get we're going to cursor through and collect all of the content document records and store them temporarily somewhere, somehow, so that we can then turn around and process them later. Now, how we store those temporarily then becomes an interesting question. This might be a place where we could drop them in platform cache.
Mm.
I don't want to write them back to the database because that seems counterintuitive.
Mm. And platform cache kind of worries me as well because, again, like everything, it comes with limits.
Yep. We're going to have to test this one. I don't know if this is really a limit.
Sure.
I suspect it probably is going to end up to be, but let's cross that bridge when we get there.
Sure.
Okay, so we've got we're going to get our records to process, and I just want to make sure that that's actually going to work like we want it to. So I'm going to change this to public for just a second, and I'm going to do this and say save that, and I'll do ldv recipes .get.
And I guess it's probably worth calling out as well that, from the scenario that we originally had, that kind of, formed this code live session, this was a migration of existing data. Normally, in the sort of day-to-day course of processing, we wouldn't be getting these kind of large data volumes. This is the case of they already had a bunch of files with a bunch of attachments on, and we needed to move that to the new S3 architecture. So, this I would hope would be like a one-off process for this particular client. But it's good to design for scale because you never know what somebody's going to import.
So we're going to call get records to process here, and I just want to see it. I'm going to give it an offset of null, because that's what we're. So if this is not null, okay. So this should be our first one, and then I'm going to run this with
anonymous.
Execute anonymous. Execute anonymous failed to run. Let's see what it says. It's on the CLI, isn't it? No. Where is the output? Apex execute anonymous. Here we go. Variable does not exist. This .chunk size. That's probably true. Because I made it static.
Yeah.
Let's not make this stat. I'm trying to test this in pieces without actually doing the whole thing, and it's going to cause me some heartache. So I'm also going to do public ldv recipes no op constructor, so I can construct this and then call this method, and it will have access to my chunk size.
Empty constructors are great unless you've got PMD installed and it keeps telling you about empty blocks.
Yeah. For whatever reason, it can't find my rule set, so I'm pretty sure there's a rule set. Ruleset.xml is right there, buddy. I have no idea what's wrong with you. Okay, whatever.
That was a previous episode.
Yeah, that was a previous episode. Okay, so now what I'm going to do is I'm going to say new ldv recipes dot get objects to process null, like that, and that should hopefully run. Execute anonymous. It failed to run. Method does not exist or incorrect signature void get objects to process. You're going to make me write a full script here. Okay, fine. ldv recipes foo equals new LDV recipes, semicolon, list of, that, by the way, is got to change.
List
It's not
of
an
account.
account anymore.
Mm.
It's content document link.
Yeah, true.
So we'll save that there. Pull that over here. Bar equals foo.get recipes. No.
It's classic variable names.
I mean, did it fail to save? It did. Legal assignment from list content document to, oh, I've got to change it.
Oh, yeah, here we go.
There we go.
There you go.
Saving. So with 9 minutes left, does anybody have any other questions, comments, snide remarks here? I think we're doing pretty good here on time. Let's see if we can't get this to actually execute. Line 2, method does not exist or incorrect signature. Get objects to process, null. Get records to process. That's... Thank you.
Yeah.
Way to go, Kevin Brain.
The joys of working over 2 tabs.
Okay.
That's when you want your split views.
Line 45, column 1. Line 45, column 1. This dot chunk size does to exist. It's right there. It's static.
It's static. Yeah.
Okay. Now we'll go over here. Try that one more time. Still failed to run.
12th time's the charm.
Variable does not exist. This dot chunk size. I don't believe you. I think variable this dot chunk size does exist. Limit this dot chunk size. Fine, I'm just gonna do it that way. So this should be, it's initialized, so every time the class is initialized we should have access to it. And now if we fail to run. Alright, viewers. Somebody says chunk size is static. That's true, but we fixed that. So this dot chunk size is no longer static.
Do we explicitly need this? Can we just not say chunk size?
And in dynamic sockle, do we have to do this? I don't remember. I thought doing the bindings worked.
Yeah, I thought bindings work because that's the whole security trailhead module kicking in.
We can always go look here in sockle recipes. Hey, I've
Here's
worked
one I
on this
prepared
before. Do we have? It's in a different file. Okay, that has been saved. No errors. Clear the buffer. And then let's try running this again. Okay, that appears to have worked. Compiled successfully, executed successfully. Look at that. So actually, let's do this. Let's say system debug, and we'll run this again. Now, fine, and then we'll say system debug bar. Okay, run that. Now, I suspect what we'll do down here is we'll find that we have no, we do have content document links. Look at that.
Cool.
Very nice. So here in this, we can process this, and if we wanted to, we could demonstrate how this would work by changing the chunk size to 1. Actually, I'm going to change it to 2. Let's change this here. Let's say bar dot size. I don't want to save it. Don't make me save it. Execute this. The output is 15. So 15 divided by 4.
3 and a bit.
So I'm going to say change it to 4. So our chunk size here will let us pull 4 at a time, and that'll get us underneath our maximum queue depth of 4 in this scratch org. So let's save that, and then instead of running this sort of manually, let's do ldv recipes. ldvr is equal to new ldv recipes. I'm not going to pass anything in because I don't have an ID yet, so that no op constructor actually makes sense here. And then I'm going to say system.execute job ldvr, and this should hopefully run 4 times. Because the execution method...
Is it execute job or enqueue job?
It's probably enqueue job. Enqueue job. Naming things is hard. Okay. So if we do this, it should run 4 times. Now, in order to show that, what I'm going to do is I'm going to go... This is the org that I'm signed into. I'm going to open up the dev console. And we're just going to have the logs open. I'm going to turn off my... my current logs only, so that'll show us everything that runs. And if we run this, hopefully, execute anonymous. Okay, that seems to have started executing it. And we've got our queueable handler. Oh, look at that. We've got an attempt to dereference the null object. Line 31. I bet you it's that offset. Line 31. Interesting.
So if it's not equal to null, set it to the offset ID. But then if it is null, we don't do anything.
That's fine. Because we're checking to see if it's null down here. But it actually threw the error on this line. Object to process size. Good old system debug.
On a side note on that one, did you see Bob Buzzard's recent blog about system.debug and the performance hit that it can have?
No.
Just the act of doing a debug and pulling that data. You know, he did some performance metrics on it, and you know, there's a cumulative impact on having system.debug in your org, because effectively it's got to go and query the things that you want to write out to the log. It's got to write it out to the log. You know.
I mean, that makes sense, but
yeah. But he's actually done some good metrics on it. He's got a blog post. So you know, for those of you on Twitter, you know, if you want to go and look up Bob Buzzard, there should be on his feed somewhere his latest blog entry on that one. It makes for some good reading.
So our constructor. Oh, you know why? Because the constructor, the no-op constructor, is not calling the get process object, the records process method. This property was null on line 31 because we were never actually calling that. So let's do that. Save that. Somebody's asking if it should not be size minus 1. I wondered if we were going to be off by 1. So this is it is 0 index. So I'm going to go ahead and do that by 1. Oh, now it's formatting things. Silly VS Code. Okay, and then we'll run this again. Go look over here. Oh, look at that. Our queueable ran. So over here we can look at the logs, and you can see that our debug statement shows that it's got those content document links here.
Yep.
And it ran 1, 2, 3, 4, 5 times. So obviously we've got a math issue here, but the final one hit that maximum stack depth has been reached. That yep. only applies in non-production orgs. That's the loophole or the beauty of queueables, and is that we can keep executing those until we run out. And you saw how quick they process. And again, this is a little arbitrary and contrived because we're not actually doing any real processing work, but that's the way it works. And I'm wondering if the reason it ran too many times is because of this -1. So if we have prog objects to process and we have 4 in there, I don't want it to come back with 3 and give me the ID. I want the actual maximum. I want the last. This is one of those times where I wish they had a last like that. A lot of other programming languages, my near and dear one, Ruby, has a last and a first method. So you can always grab the first object and the last object in a list. I'm going to save this here. We'll see if this gives us an offset, an index on a bounds error when we run this again.
This is the nature of coding, substituting one error for another, substituting one governor limit for another.
Yeah.
The cycle continues.
It's the circle of dev. Anyway, so we've got the maximum index out of bounds. Okay, so let's do this. You're right, we did need to negative offset that one. And then down here, our chunk size is mutable now. We took off the final. We could make this 5. I'm gonna put the final back there. I don't want that editing. But unfortunately we are at time. So I'm gonna do one last run here. I'm gonna clear the test thing. Clear the log panel. Or not.
And again,
sure.
Another thing that you'd probably want to do in real life production code is those chunk sizes, batch sizes, etc. You're going to want those in some admin configurable place. You're not going to want to hard code those limits in there.
Exactly. Or you want to calculate the limit when you fire it up.
Yeah, like we talked about earlier.
It's either going to be 50,000 or 75% of the max record count.
Absolutely.
All right, so I think that's a great place for us to stop and pause for the day. Thank you all for tuning in. I look forward to seeing you again next week. Rob, thank you for joining me. This has been a lot of fun. And remember, the key takeaway of this is, how do you eat an elephant? One bite at a time. And queueables are one way in order to do that. So thank you much for tuning in. See you again next Thursday.
Thanks, everyone. Take care.